Well, now we get to apply algebra to the relationship in triangles. It's always my favorite, applying algebra to geometry. And remember now, we're talking about the hinge theorem, which is basically, or another way of stating that is the angle-side angle inequality, or the converse of the hinge theorem, which we could say another way is the side-side-side inequality. And so let's see here. We got two triangles. And let's see what we're told here. Well, we're told that this side's congruent to that side. And we can see that the 50s are congruent. Sides that were given a measurement of 50. And then we're told that this side is 47, but this is 5x plus 2. Now, what else do we see here? Well, we see that this is a 68-degree angle measurement. Side, angle, side, and this one over here is 55. So this included angle of 68 is obviously greater than the 55, which means that this measurement here of 47 is going to need to be greater than 5x plus 2, or we could flip that and say that 5x plus 2 has got to be less than 47. But by how much? We don't know. So we got two cases here. We're going to have one case where we're going to solve that 5x plus 2 is going to be less than 47. This is our hinge theorem. We get that from the hinge theorem. But we don't know exactly what that measurement's going to be. It can be anything, but it's one thing it can't be. It cannot be less than 0. So we could also say in our case 2 that 5x plus 2 has got to be greater than 0. And that's going to help us find the range of values. It's got to be less than 47, but it must be greater than 0 because the length of a side cannot be negative. Now, x itself could be negative, but the total length cannot be negative. Okay, so well, then let's just solve our two cases. Over here on the left, we got 5x plus 2 is less than 47. I'm going to subtract 2 from both sides. That's going to leave me with 5x is less than 45. We're going to divide both sides by 5, and so x must be less than 9. Now what about our case 2? Well, we're just going to add 2 to both sides. So 5x has got to be greater than 2. And we're going to divide both sides by 5. And so x is greater than 2/5. Or if I put 2/5 in it as a decimal, that would be the same as 4/10 or 0.4. And so then in expressing my range of angles, 0.4 has got to be less than x, or x has got to be greater than 0.4, but x also has to be less than 9. So there we are applying algebra to relationships in triangles, and the theorem that we used to do so was the hinge theorem, or the side angle side inequality. Algebra to geometry. Algebra to geometry.